Today we're going to talk about putting an equation into slope-intercept form. So when we're graphing in slope-intercept form, we need to first make sure that the equation is in slope-intercept form, which is y equals mx plus b, by solving for y. So most often what's going to happen is something is in standard form and we want to rearrange it so that we have the y-intercept and we have the slope to be able to graph it. Once we have those two things, you want to start with the y-intercept, so identify and graph that point, and then from that point, use the slope, which is rise over run, to graph as many points as possible. Once you have all those points, you can connect them using a straight edge. So first example, we're going to graph 5x plus 4y equals negative 28. We've already talked about potentially just finding x and y intercepts and graphing those in the event that something is in standard form. That won't work in this case though, because 5 does not go into negative 28. So we're going to end up with a decimal, which is not great for graphing. So to graph this, I want to first figure out what this is in slope-intercept. So I'm going to take 5x plus 4y equals negative 28, and I am going to solve this for y. So I want to get the y by itself. So I'm going to move everything else from the left-hand side to the right-hand side. So I'm going to start with moving the 5x. And this is just like the literal equations that we did earlier on in the semester. So now I can cancel that out. I get 4y equals, and because I'm rearranging it into mx plus b, I want the x to be first. So negative 5x minus 28, and then I'm going to divide everything by 4. And it's okay that the 4 doesn't go into the 5 because that's my slope. So that's just going to end up being a fraction. So we get y equals negative 5 over 4x, and then minus 7. Okay, so this is my slope-intercept form. Y equals negative 5 over 4x, and then minus 7. So my slope is going to be this number right here, and my y-intercept is the negative 7. Again, we just need to be careful when we're writing the y-intercept that we write it as a point. So the slope is negative 5 over 4, and the y-intercept is at 0, negative 7, because it's a coordinate. Okay, so to graph it, you're always going to start here. So start with your y-intercept. This is my y-axis. So I'm going to start at negative 7, and then I'm going to go up 5 and over 4. Now, negative slope is going to go in this direction. So you can either go up 1, 2, 3, 4, 5 over 1, 2, 3, 4 to the left, or you could go down 5 and right 4. We don't have room to do that, so we can only go up 1, 2, 3, 4, 5, and then to the left 1, 2, 3, 4. Okay, so now I've got here and my y-axis, and I am going to connect those points. You're going to want to use a straight edge to make sure that your line is close to perfect. All right, so to get f of negative 4, two different ways that we could do it. Again, we could take negative 4 and we could plug it into this function up here, and we would plug it in for x, since this is saying that x equals negative 4. If you graphed all the points on your line though, we can also find it this way. X equals negative 4 is right here. So if I look to see where it hits my line, it hit right here, which is at negative 2. So this is why it's important to graph as many points as you can with the slope to help you with these function notation problems. So on the second one, this is saying that my output is 3. So y equals 3. So I'm going to go on my y-axis to 3, and I'm going to see where it hits my line, which is right here at -8. Okay, so the last question is for -12 a solution. So if I look at my graph, it's somewhere over here, it looks like it could be a solution, but to check, I need to actually plug those values into my function. So I need to do 5 times 4, since x is 4, plus 4 times -12, since y is -12, and check to see, is that equal to -28? So 5 times 4 is 20. 4 times 12 would be -48. Is that equal to -28? And it is. So since -28 equals -28, and that is a true statement, then we can say yes, this point is a solution. So example 2, we're going to graph 2x minus 3y equals 12 by rearranging into slope-intercept form. So the first step to rearranging is going to be to move x to the other side of the equation. We want it to end up being y equals. So since it's a positive 2x, we can subtract 2x from both sides, bring down what's left, so we have -3y equals, and as a reminder, on the right-hand side, I cannot combine 12 minus 2x. So this would be -2x plus 12. And I'm putting the x first because I want it to be in slope-intercept form, so the variable and then the constant. And now my last step would be divide everything by -3. And now just be very careful with your signs. So we have a negative divided by a negative, which will become a positive, and then we simplify that fraction. So since it doesn't simplify, it's going to stay 2/3 x, and then a positive 12 divided by a -3 is a -4. So my slope-intercept form is y equals 2/3 x minus 4. So looking at that equation now, my slope is going to be the coefficient of x, so that would be 2/3. Okay, so that number is right here. And then my y-intercept is b, which is at the end of the slope-intercept form. So that's going to be -4, but written as a coordinate. So that coordinate point would be 0, -4. So now to graph that, we want to start always with our y-intercept. So we're going to plot a point at -4. And then my slope is rise 2 and then run 3. And it's going in a positive direction. Rise 2, run 3. Rise 2, run 3. And I'm going to go in the other direction as well. The more points that you get, the easier it's going to make the function notation problems next. Rise 2, run 3. Down 2, left 3. Okay, and then we can connect those points. You would want to use a straight edge to connect those points. Okay, so f of 9, this is telling you right here that x equals 9. So we know our x value, we're trying to find the y value. So we're going to go on our x-axis over to 9 and see where it hits my function, and it hits at 2. So the y value is 2. For this f of what equals 0, we're trying to find x, and it's telling us that y is equal to 0. So I'd go on the y-axis to 0, which is right at the origin, and so I'm looking for where it hits here. And make sure you're looking at your points. My line is a little bit off, but the x value would be 6. So f of 6 equals 0. So for our last question, is the point 2110 a solution? So first we always want to look at our graph and see, is that a point that my line crosses through? That would make it a solution. This point is obviously not on the graph, so then I would need to use my equation to determine if it's a solution. So I'm going to substitute 21 in for x and 10 in for y and determine if it's a true statement. So 2 times 21 minus 3 times 10, does that equal 12? So 2 times 21 is 42, minus 30, does that equal 12? And it does. 42 minus 30 is 12, and 12 equals 12. So yes, that point would be on the line, and yes, it is a solution. So our next example, we're going to graph y minus 4 equals 1/3 times x plus 9. So first I need to rearrange this into slope-intercept form. So y minus 4 equals 1/3 times x plus 9. So what I'm going to do first is distribute this 1/3 rather than getting rid of the fraction, because right now my y value doesn't have a coefficient. So if I multiply everything by 3, then I'm going to end up with a coefficient there, and it's going to be a little bit longer to solve. So if I distribute, I have y minus 4 equals 1/3 x plus 3, and then I can just move the 4 over and I'm done. Okay, and when I move it to the right-hand side, I want to combine like terms, so I can combine it with the 3 that's already there. So we get y equals 1/3 x plus 7. And that is my slope-intercept form. Y equals 1/3 x plus 7. So my slope is 1/3. And then my y-intercept is at 7, but again, making sure that we write it as a coordinate. Okay, so to graph this, I'm going to always start here. So I'm going to start on my y-axis at 7. And then I'm going to count rise 1, run 3. And because this is positive, I know my graph is going to go in this direction. So I'm going to go up 1 over 1, 2, 3. Up 1 over 3, and again we want to graph as many points as we can in order to help us answer our function notation problems. Okay, so then from there we can connect all of our points, and that is our line. All right, so to get f of 6, this is telling us that x is equal to 6. So I'm going to go on my x-axis to 6, which is right here, and I'm going to look to see where it hits my line, which is here, and the y value is 9. All right, for my second example, this is giving me my y coordinate. So this is saying y equals 4. So if I go on my y-axis to 4, that's here, and it hits my line here, which is at -9. All right, so is the point -15, -6 a solution? So to determine this, I'm going to use my equation, and you can use your original or you could use your slope-intercept form if you wanted. Either one would work, okay? So I'm actually going to use the slope-intercept form since it's a little bit shorter. So this is x and this is y. So I want to see, does -6 equal 1/3 times -15 plus 7. So 1/3 times -15 is -5 plus 7, that's going to give me 2, and -6 does not equal 2. So the answer here would be no, -15, -6 is not a solution.